Hello guys, I am Cheriyan. Let us do the application problems of differentiation. If a snowball melts, snowball is in the shape of a sphere, okay, sphere. Melts so that its surface area decreases at a rate of 1 centimeter square per minute. Find the rate at which the diameter decreases. When the sphere melts, the diameter also decreases. So we need to find the rate of the diameter, rate of change of diameter with respect to time. Find the rate at which the diameter decreases when the diameter equals 10 centimeter. When the diameter equals capital D, capital D. Okay, radius. When diameter is 10 centimeter, what is radius? Radius is 5 centimeter, the half of diameter. Okay. What is the surface area of a sphere? Surface area of a sphere is 4 pi r square. You need to remember that. Surface area. Outside area. The curved surface area. The sphere has only one curved surface area. That is 4 pi r square. Okay, differentiating both sides. What are the given quantities? What is 1 centimeter square per minute? That is dA by dt. Rate of change of surface area with respect to time is 1 centimeter square per minute. Find the rate at which the diameter. We need to find out d by dt. Rate of change of diameter with respect to time. We are going to find out d by dt. Okay. A is equal to, so I am going to change this pi into 4r square, okay. That is A is equal to pi into, what is 4? 2 square r square, right? So A is equal to pi into 2r the whole square, right? Oh, that is, I think this is fine. Okay, find dA by dt. dA by dt equals, what is that? 4 pi into, what is the derivative of r square? 2r dr by dt, right? So what is, okay, dA by dt is 1. We can substitute the values. Before substituting the values, see, 4 pi, I am going to write r first, then 2 I am going to bring it inside the derivative, because I am going to, that is 2r is equal to d, right? So when you substitute d into 2r, I am going to bring this 2 inside by dt. This one is capital D. Okay, we are going to find out that 4 pi r into d capital D by dt. We are going to find dd by dt. What is r? R is 5. 5 into 2, 5 into 4, 8, 20. 20 pi d by dt equals 1. dA by dt is 1. dA by dt is 1. So 1 is equal to 20 pi capital D by dt. What is capital D by dt? Dividing by 20 pi on both sides. Dividing by 20 pi on both sides. So d capital D by dt equals 1 by 20 pi. Okay, that is the answer. What is the unit? The unit of diameter is centimeter and time minute, centimeter per minute. Okay, that is the answer. One more time. What are the given quantities? dA by dt is 1. Diameter is given, that is 10. Then what is radius? Radius is 5. 2r is equal to d. See, differentiating, a is equal to 4 pi r square, differentiating both sides. dA by dt equals 4 pi constant. Derivative of r square is 2r. Then chain rule, derivative of r is dr by dt. 4 pi r into d 2r by dt. What is 2r? Capital D. We are going to find out d capital D by dt. So the answer is 1 by 20 pi. Okay, next one. Two cars start moving from the same point. One travels south, one travels south. See, from the same point, one travels south at a speed at 60 miles per hour. That is the speed. And the other travels 25 miles per hour to the west. This one is 60, the other one is 25 miles per hour to the west. At what rate is the distance between the cars? At what rate? We need to find out the distance between the car. When the car is here, the other one is here, the distance between the car is this one. Okay, that is, I am going to put C. This one is X. This is actually dx by dt. This is actually dy by dt. The distance is y. This one is x. So, distance, okay, 16 miles. At what rate? At what rate is the distance between the cars increasing? Between the cars increasing 2 hours later. Okay, 2 hours later, what is the car in the x direction travels? 1 hour 25 miles, 2 hours 50, x is equal to 50. Okay, the second car or the first car in the y direction, after 2 hours, how much it travels? 1 hour 60 miles. So 2 hours 120 miles, right? So we need to find out z when x is equal to 50 and y is equal to 20. Because what is the relation between z, x, y and z? What is the relation? Z square equals x square plus y square. That is Pythagoras theorem. Just differentiating both sides with respect to time. 2c dc by dt equals 2x dx by dt plus 2y dy by dt. Okay, 2 we can cancel out. Okay, so what is z? We are going to find out z. X is 50, y is 120, then what is c? That is the question. Okay, that is what we need to find out. Okay, z, I'm going to, c is equal to square root of, what is that, 50 square plus 120 square. Okay, 50 square is 2500. The 120 square is 14400. So when you add these two, 169 16900 equals 130. Okay, equals 130. Okay, C is 130. I'm going to put C 130. dc by dt we are going to find out. See, at what rate is the distance between the cars? That is dc by dt. dc by dt is the question. dc by dt equals question mark. Okay, 130 into dc by dt, and what is x? X is 50. 50. What is dx by dt? 25. Right? That is the speed. Plus y 120 into what is dy by dt? 60. So just add these two. Multiply these two. 125 0 plus 7200 7200 1250. When you add 6450, square root of 6450, no 6450, we don't need to find out the square root. Okay, 130 dz by dt equals this. We don't need this guy here. Dividing by 130. So 130, I think this is 65. 30 times 65. Zero cancel. Yeah, this one is 8. Yeah, 8. Yeah, 65. That's right. So this is the answer. Okay, 65 is the answer. Alright, say the relation, find out the relation between z, x and y. What is that? Z square, Pythagoras theorem. C square is equal to x square plus y square. Differentiating both sides. Find the quantities here. Say z is 130 by applying the Pythagoras theorem. So when z is 130, what is x? X is 50 and y is 120. Okay, when z is 130, x is 50 and y is 120, then the speed of the first car in the x direction is 25. The speed of the second car in the y direction is 60. So just substitute everything, you get the answer. Okay, the last one. if two resistors with resistances R1 and R2 are connected in parallel as in the okay, then the total resistance R is measured by, then the total resistance that is in physics 1 by R is equal to 1 by R1 plus 1 by R2. Okay, that is the, see, these are the parallel connection. Okay, this one is R1, this one is R2, this is the total resistance. We get the resultant resistance here. Okay, that is R. 1 by R is equal to 1 by R1 plus 1 by R2. What is the question? If R1 and R2 are increasing at the rate of, if R1 equals increase, R1 and R2 are increasing at the rate of what? Rate of 0.3 ohms per second and 0.2 ohms per second. That is respectively. That is R1 dR1 by dt equals 0.31, 3 ohms, and dR2 by dt is 0.2. Okay, that is important. Then how fast is the capital R changing? We are going to find out d capital R by dt. That is the question. When R1 equals 80 and R2 equals 100. That is the question. Okay. All right. See, first I am going to take this one and simplify. 1 by R is equal to R1 R2 LCM. Then this one becomes R1 and R1 plus R2. So I am going to differentiate R. Okay. So I don't need this 1 by R. So I am going to take the multiplicative inverse. Just switch the numbers. That is R is equal to, when you switch here, this one also you need to switch. R1 R2 by R1 plus R2. So I am going to erase this and I am doing the okay. See, dr by dt equals, I am going to use the quotient rule, d by dt of u by v. What is that? V into derivative of u minus u into derivative of v by v square. That is the formula. So here R1 plus R2, that is v. This one is v. Numerator is u. Derivative of u. There are two variables here, so you need to apply the product rule. First one, R1 into derivative of R2, dR2 by dt, dR2 plus R2 into dR1 by dt. Okay. Then minus u into numerator R1 R2 into derivative of the denominator. That is not, you don't need to apply the product rule. Derivative R1 plus derivative R2. dR1 by dt plus dr2 by dt. Okay, divided by r1 plus r2 the whole square. Okay, so r1 plus r2, what is r1? R1 is 80 plus 100. Alright, 180, right? R1 plus R2, 180. I'm going to write everything. 80 plus 100. What is R1? 80. What is dr2 by d1? dr2 by d1 is 0.2 plus what is r2? 100. dr1 by dt? 0.3. Close the bracket. Okay, then next minus r1 into r2. 80 times 100. Then plus dr1 dt plus dr2 dt. dr1 dt is 0.3 plus 0.2. 0.3 plus 0.2 divided by all divided by r1 plus r2, that is 180. 80 plus 100, 180 the whole square. Okay, now simplify. 80 plus 100, 180. What is 80 times 0.2? 60 plus 100 times 0.3, 30, right? Plus 8000 times 0.5 divided by 180 square equals 180 times 16, that is 46. 180 times 46 plus this one is 4000. See, 8000 times 1 by 2, this is half. That actually 8000 divided by 2, that is 4000 divided by 180 square. One 180 times 46 plus 4000 divided by 180. 180 square, that is 18 square is 32400. I am going to use the calculator. One 180 times 46, 82 8240, sorry, 8280 plus 4000 by 324 plus 4000 divided by 32400. Let me see. 16, 46. One 180 times 46, 8280 plus 4000 divided by 32400. Okay. dr2. I made a mistake. See here, minus, 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 minus. That is 8280 minus 4000 equals 4280 divided by 32400. Yeah, this is the answer. 1.132 ohms per second. That is the resultant resistance, the rate of change of resultant resistance is 0.132 ohms per second. Okay guys, this is the formula. You need to remember the formula first. They will give the question, you can see the formula. 1 by R is equal to 1 by R1 plus 1 by R2. You can see this formula, but you need to simplify this. You know why we are simplifying this? Because we are going to find out dr by dt. If you do like this, it is difficult to differentiate. So you need to find out R. R is equal to R1 R2 divided by R1 plus R2. So that is, you need to remember little algebra. That is very simple. R1 and R2 take the LCM. Then R1 plus R2 on the top. Then take the reciprocal. That's it. So here you need to remember only one thing. What is dr2 by d1? That is the second rate of change of the second resistance with respect to time is 0.2. That is, if you write 0.3, the answer will be different. So the the rate of change of second resistance is 0.1. The rate of change of the first one is 0.3. You need to substitute in the right position. Then only you get the right answer. Okay. Thank you guys. Thank you. See you then.